Good day once again. In our previous discussion, we tried to discuss the equation of motion of a undamped free vibration response of a single degree of freedom systems. So now we will be considering the damped free vibration response. So again, no, a free vibration response. Uh, When we say free vibration, it means that the dynamic or external dynamic force is equal to zero or set to zero. But the structure, there is a vibration on a structure. There is motion or oscillation happening sa ato ang single degree of freedom sa structure. So if you recall that this is our auxiliary equation for our equation of motion nga mu double dot of t plus cu dot of t plus ku of t is equal to 0. So since the damping here, we already considered the damping on this specific equation, on this specific condition or vibration response, RC is not equal to 0. So now na put a new set of equation of motion here. So for each system, atay general equation of motion, which is this one. And then we try to solve equation of motion for each condition. So last time we have the undamped condition. Here we have the damped condition. So we have a quadratic form equation in this form. And then by quadratic formula, so to solve that quadratic equation, we just use quadratic formula. S is equal to negative C over 2. Or if you, let's recall first the equation or the quadratic formula. So the quadratic formula is just equal to S is equal to negative B plus or minus the square root of B squared minus 4AC over 2A. So here we have S is equal to negative B or negative C over M plus or minus the square root of C over M squared minus 4 times A, or A is 1 and C is K over M over 2A or 2. So kana siya no, we can ato na silang matagsa, that will become negative C over 2M plus minus the square root of C over M squared minus 4K over M all of times 1 half. Now kani si 4, pwede na to siya ipagawas, no? We try to factor that out. We will have negative C over 2M plus minus 1 half times, so ipagawas, we factored out 4, then we will have C over 2M squared minus K over M. So the square root of 4, that is just 2. So eventually, makancel din yung 2 direct. Pag magawa si 4, that will become 2. Makancel ang 2. Then, resulting solution will have S is equal to negative C over 2M plus or minus square root of C over 2M squared minus omega squared. Because K over M is omega squared. Now, ang characteristic ani ni S depends on the sign of this term. Depende sa yung sign. If this term is greater than 0, then we have distinct real roots. We have two roots of differing values. If that is a greater than 0, that is our case 2A. Remember, our case 1 is an undamped free vibration response. In our case 2, this is a damped free vibration response. Case 2A, C over 2M squared, quantity C over 2M squared minus omega squared is greater than 0. Our case 2B, the equation we'll have a complex conjugate root. So, sa mali. Complex, pasabot we have an imaginary again. That is a negative square root. We'll have I on case 2b. If our c over 2m squared minus omega squared is less than 0, and if they are equal to 0, then we have real double roots. No, so this if we have that is 0, we will have s is equal to negative c over 2m. This will be our roots for case 2c. So that are three conditions for a damp-free vibration. But let's start first with our case 2b. So sa ganito si case 2b, ingon siya na sa no, c over 2m minus omega squared is less than 0. So by rules of our inequality, no, we have c over 2m squared is less than omega squared. We stuck to square root the both sides. You'll have c over 2m is less than omega squared. Omega rather, or c is less than 2 times mass times the omega. So this is our case 2b. Our c or our damping coefficient is less than the 2 omega 2m omega. So what is our 2m omega? This is we call this our threshold value or limit. This is our boundary for our damping. So now we introduce another notation, the C or C sub C. We call this our critical damping. This is the 2m omega. We have another value. We have the Greek alphabet. In English, this is xi, spelled as xi. This is xi or xi or xi, c in the Greek alphabet. So this is represents our damping ratio. That is the coefficient of damping of the object over the critical damping. So this is our critical damping. So now again we have our CC and then another notation. So here this is an underdamped system because we have our critical damping here at 2m omega and then it is lesser than the critical damping. We call that the underdamped system. So for an underdamped system, our xi is greater than 0 but less than 1. So ganong less than 1 man because this is just the ratio of the damping rate, critical damping ratio is just the ratio of the damping coefficient of damping over the 2m omega. So if equal na sila 2m omega, if C is 2m omega, so that will be equal to 1. But since this is less than this is less than the critical damping ratio, that's why the damping ratio is greater than 1 but less than 1. So since naman tayo newly added na notation, and we know that since we have another notation, and we know that S is equal to negative C over 2m plus or minus, we have the square root of C over 2m squared minus omega squared. If I apply this critical damping ratio on this equation, so we know no, from this equation that so we have a damping ratio is equal to C over 2mw omega. And then therefore our C here is 2m omega psi. So if we apply the value of C here, we will have S is equal to negative 2m omega psi over 2m minus square of 2m omega psi over 2m squared minus omega squared. So si 2m makancel. We are left with negative xi omega minus square root of omega squared xi squared minus omega squared. So ato lang di-distribute si power nga 2. Then kanisa diri sa sulod, we just factor that. We will have negative sa here omega plus or minus square root of omega squared times xi minus 1. Since we know that the xi should be less than 1 but greater than 0, so this will yield a negative result. So if we apply that negative value there, so muna siya as if no, so mapagawas na si omega square root of omega squared is omega. So it seems like there is a negative 1 here, and then we have in 1 minus the xi. So this will yield the result of xi omega plus or minus. We have the I omega square root of 1 minus, sorry I forgot this square. We have the xi squared. Then we have another here, they have the omega d. This is the natural frequency, the damping frequency. And then this is its formula. And then it is just substituted there, no, instead of this one. So our S, instead of positive and negative I omega from the undamp condition, here, our S is already, we have a negative damping coefficient xi omega or minus I d. So this is the damping. The damping is already involved in this one.